Hey, what's up, kids? We are back, Mr. Murray's Mathland, doing some law of sines, and today we are talking about solving a triangle having these measurements, and specifically we're going to be talking about the what we call the ambiguous case in this section. And here's what we mean by this. Look what's given here. Solve the triangle having these following measurements, and I'm just going to draw a generic triangle to help me visualize some things. If I really wanted to try to draw it to scale, I might. Um, You can put angles A, B, and C anywhere you like. Angle C is 48 degrees. Lowercase b, and remember that stands for side B, which is across from angle B. So this is angle B. Side B would be right over here. So that's the side that's 28. And side C, which would be across from angle C, so that would be right here, is 10 units long. So notice, here's what we mean by the ambiguous case. What is given to you is you are given two sides and an angle, but notice it's not the angle that's included between the two sides. Meaning here's the two sides and the angle that's between them would be angle A. That would be side, angle, side, which we know is a postulate in geometry, which proves congruence, but this is a non-included angle. So you may remember that is not a postulate, ASS. Oof, naughty word here, or we'll reverse it here to keep things PG. But when you have what's called the side-side angle case like this, side-side angle, two sides and a non-included angle, that is what we call the ambiguous case. That means you could have 0, 1, or 2 triangles possible that exist with these measurements. And sometimes it's harder to tell than others, which one it is, but we're going to just jump in here. Okay, so always good to identify when these problems are all mixed up together before you just start solving away, is take a look at what you're given. Is it side, angle, side? Is it side, side, angle? Is it angle, side, angle? Because if it's an ambiguous case, if it's side, side, angle, you want to be on extra high alert. So here's one way to tell. We're going to talk a couple different ways here, I think, in these videos, but one way is to just jump in and try to solve for what you can. And you have an angle side pair of angle C and side C, and you only have one side, and that would be B. So the only thing you could potentially find is angle B with that, and that's what we're going to do here. Okay, so the sine of angle B divided by side B, which is 28, is equal to the sine of our known angle, which is 48, divided by that opposite side of 10. And to solve for angle B here, I'm going to isolate. I'm going to multiply both sides by 28. So that will be 28 times the sine of 48 degrees, all divided by 10. And to solve for B, I'm going to take the inverse or arc sine of each side. So B is the inverse sine of 28 sine of 48 divided by 10. Okay, so that would be a solution for B if I didn't have a calculator. But now let's just jump in and see approximately how much is that. Whenever you're in this kind of unit and about to use trig buttons on your calculator, you might want to check your mode. We are in degree mode, and that's what you want for these problems. These angles are measured in degrees. So let's see, inverse sine of 28 sine of 48 divided by 10. Notice I have that all in the inside of my inverse sine expression. And you see what the calculator gives you, some sort of non-real or error message. That is the way of telling you that this cannot exist. This scenario cannot exist. So this is a zero triangle possibility. And here's really the problem, is that inner expression there, 28 sine of 48 divided by 10. Notice how much that is. That's 2.0808 if you were to just reduce this right here. And you're saying the sine of some angle equals 2.08. And you should know by now, you get to this point, the sine of an angle can never be bigger than 1. So if this value is bigger than 1, this is an impossible scenario. There's no angle that can exist. So that would just be a way to tell you that there's no solution. There's, however you want to say this here, 0 triangles exist. And that would be a potential when you have an SSA. So, it shouldn't be that surprising. Okay, so let's just check out another example or two, just so we see a variety here. Again, I'm given a few measurements here, so I might just draw a generic triangle. And I'm given angle C again is 48 degrees, side B is 28, and side C is 35. So again, taking a good look at what I have here, 2 sides, but not the included angle. 2 sides and a non-included angle, that is SSA, side-side angle, ambiguous. So just be careful, 0, 1, or 2 is possible. And one way to do it is to just jump in and start finding what you can. I've got my angle side pair of 48 and 35, so let's do this. The angle I'm forced to find, since I have side B, I'm forced to find angle B. This being side A over here and across from angle A, and I don't have either one of those. So let's go for it. Sine of B divided by side B, which is 28, is equal to sine of 48 degrees divided by 35. And just like we did on the last problem, I'm going to multiply by 28, and I'm going to take the inverse sine of all that. So I'm just going to jump right to angle B will be the inverse sine of 28 times the sine of 48 degrees, all divided by 35. And now, let's bring that calculator back out here. Inverse sine of 28 sine of 48 divided by 35. Ooh, there we go. Forgot the division sign. And we get that angle B has a solution of 36.48 degrees. We didn't say how to round here, so we'll go 2 places. 36.48 degrees. Now what you have to remember, and this is again, be on high alert when you're solving a side-side angle scenario, is that when you do the inverse sine, that step right there, you have to remember there's 2 potential answers. There's 2 angles that will have, this value as its sine, right? There's a quadrant 1 solution, which your calculator will give you, unless it's a no solution, and like in the last problem, you'll get no real solution. So we got 1, and there's at least 1 answer, but there's always a quadrant 2, right? There's 2 angles, to use a unit circle angle. There's 2 angles that have a sine that equals positive 1/2. There's 30 degrees in quadrant 1, and there's 150 in quadrant 2. So to find the second solution of this, you have to consider the supplement of 36.48. That would be the quadrant 2 angle with that reference angle. And so that would be 143.52. So what you have to do, though, that's the second answer mathematically that would make sense, that would have this value of a sine of this fraction, but you have to make sure that that angle could potentially exist in this triangle. So you look at this triangle, the measurements that are given here, angle B, could this angle be 143.52? You should be able to look at that, and the one existing angle we know is 48 degrees, and know that this is an impossible scenario. Because if you add these 2 angles together, they're going to be bigger than 180 already, and you won't have any left over for angle A. So this second possibility, while it makes sense, while it has this same value, it's not a possibility in this triangle. And the other way to think about that, these are all like little geometry properties and trig properties. You know, the more you know, the better, I guess, is that when you look at this original triangle, this side is bigger than this side. So we knew that angle C has to be bigger than angle B. And when that's the case, that means that second possibility, that obtuse possibility, couldn't possibly be an answer, because how's it going to be? You know, it's got to be less than 48 degrees. That's what we know. Okay, so we did get one answer here, 36.48 degrees, and now we have to finish off the triangle. We got to find angle A, and we got to find side A that goes with that. So angle A, that's easy. Now that you know two of the angles, you can just subtract those, the sum of those from 180, right? Three angles of a triangle add up to 180, so 48 plus 36.48, subtract that from 180. $95.52, and yeah, it probably would have just been faster to do it in my head, but I was feeling a little lazy there. Okay, 95.52, now we know angle A, and now that we know angle A, we can use that in the law of sines to find side A. So I would still stick with the original angle side pair you were given, which was angle C and side C, because that way nothing's been rounded. Well, actually A was slightly rounded, and we'll talk about how to handle that if you like. But here's what I know. Angle C, sine of 48 over 35 is equal to sine of A, which is that 95.52 degree angle I just found, divided by side A. Okay, so now just doing a little manipulation with your proportions, you multiply by A, you divide. You're going to have A is equal to 35 times sine of 95.52 degrees divided by that sine of 48. And I'm going to go to the calculator now and get that approximation for that. So let's see, 35, if I type it in just as is, 35 sine of 95.52 divided by sine of 48, you get about 46.88. And there's your third side there. One problem is, you know, what if that bothers you that I used a rounded angle, that 95.52, you know, was slightly rounded off to the nearest hundredth. So what if this answer isn't 100% accurate? So you could, you know, always go back to where that came from, and you know, that 143.52 right there that we used. You could go 4, 5, 6, 7, or use the whole expression on your calculator and, you know, not round off. So you know, if you wanted, you could do that, but that's not really what this video is about. We're just really trying to get you to find these answers. So there's a case where there was only one triangle possible with those measurements there, and again, that second possibility, that supplement, was too big to have in this triangle. And so let's take a look at this third example here, and you may be able to see where we're going with this. That I've given you angle C is 48 degrees. Angle C is 48. Side B is 28. Side C is 24. Let's put that there. I don't know. And again, this is a side-side angle scenario, so watch out. It's 0, 1, or 2. And to determine, maybe you just jump in and start finding stuff. So, okay, so I'm going to start with finding angle B. Okay, so sine of b over side 28 is equal to sine of 48 degrees over 24. Going to multiply by 28, going to take the inverse sine. You know, these manipulations you get pretty good at when you get 2 or 3 days into this unit. So 28 times sine of 48 degrees divided by that 24. We're taking the inverse sine of it. And so here we go, inverse sine of 28 sine of 48 divided by 24. And we get about 60.11 degrees, 60.11 degrees. So we did get an answer, but what about the second possibility, the supplement there? So the supplement, 180 minus 60.11. This calculator likes to give it as a fraction, so that would be 119.89. Right, that's just quadrant 2. It's going to have that same sign value. But is it a feasible solution in this triangle? Could angle B be 119.89? And just think about 119 degrees along with 48 degrees. If you add those two together, they are still less than 180. So that means this is a viable second solution. That means you have two triangles. You know, you got one because there was a solution. And when you get one, you got to check its supplement. And in this case, it's not too big. So you have two triangles. And that's the most work here, because that means you got to try to stay organized here. And think about, you know, case one. I'm just trying to be, again, orderly here. And that's where angle B, and so I'm going to write B1, you know, the subscript there, 60.11. In case 2, B2 is that second possibility of 119.89 degrees. And we're just going to, you know, proceed from there. So not that you have to redraw the diagram. You've got a perfectly good diagram above there, and it's all just to help you visualize, but if that really helps, remember what you're trying to find now is what's the angle A that would go with that, and therefore what's the side A. So we find the third angle by adding and subtracting from 180. So that's why I'm going to call this A1 if this, you know, goes with B1 in this first triangle possibility. So that's going to be 180 minus the 48 plus the 60.11. And so that's going to be 71.89 degrees. Okay, so we found the third angle in this possibility, and now let's find the third side. So we use our law of sines, and again, I'm going to stick with the angle I was given, 48, sine of 48 over that opposite side of 24, C and C. And I'm going to set it equal to sine of, now that I know A, 71.89 degrees, divided by side A1, and do a little manipulation, you know, cross multiply, divide, whatever you want to say here. That will be 24 times the sine of 71.89 divided by that sine of 48 degrees. And so the side, final side on this will be 24 sine of 71, divided by sine of 48. And we have that side A1 in this case will be about 5.12. And, you know, kind of a quick measurement check here. Notice in this scenario, and you see, I just caught myself. I just started looking at this, and angle A is 71.89. That's the biggest of the three angles. So I started looking, and side A was 5.12. Why is it not the biggest side? And it's just the most simple mistake. I look back, and that's the typing on this like iPad. I just missed a digit there. I was supposed to type 24 times the sine of 21.8 times sine of, or divided by sine of 48. So I missed the 2. And now, there we go. That makes a little more sense. That side A1 will now be 30.695 or 30.70 if you like. And now that makes sense. That would be the biggest side. So at least it's not some kind of obvious mistake. And yep, that's why you always check those kinds of things, kids. All right, so that was just solving that one triangle, but now what about case 2? It's not any harder. It's just trying to stay organized with all this info. Case 2, we have found that B could potentially be this 119.89. So if you're looking for the visual here, that means that B could be an obtuse angle. Here's the C that's 48 with the side 24 across from it, and side B is 28, but instead of being an acute angle, it's 119.89. And so you're trying to find the missing angle A in this case, and the side A that goes with that. So let's go here. If this goes with B2, then I'm going to call this A2. And A2 would be 180 minus the two angles we know, which is that 48 plus 119.89. Whoa, it's like I got an ad on my calculator there. That's what happens when you get these free things. Okay, so you're getting the real warts and all presentation here, kids. Just trying to give you a real slice of life here. So angle A in this case would be 12.11. Notice when B is acute, or sorry, when B is obtuse, it really leaves a very little sliver for angle A. So that would make sense that it's now going to be a pretty small angle of 12.11, which should mean this side should now be the smallest side. So I'm going right back to sine of C, which is 48, divided by side C, which is 24, is equal to sine of A, which in this case is 12.11 degrees, divided by little A2, side A2. And it's the same manipulation. So same setup here, 24 times sine of 12.11, except that's 12.11 now instead of the first scenario. So I really can just go back on my calculator, grab this last expression, and I could just change that inner angle to 12.11. And so we see that in this we get side A2 would in fact be pretty small compared to the others, and that would be about 6.78 units long. Okay, so there's everything, and it looked, can get pretty messy here. So you try to stay organized with the given information, but there's what we have there, and you try to maybe group them together or label them in some way. Don't just have a bunch of things all floating around here, but have those measurements for the first triangle or in that second triangle, which does happen sometimes in the side-side angle scenario. you get 2 triangles, and those are those measurements. So hopefully we showed you a variety here of the ambiguous case. When you have 0 triangles possible, how to tell. When you have only 1 triangle possible, how to tell, and that's when that supplement is too big, or when that supplement fits here, like this was the case, you get 2 triangles. And in that case, you stay organized and just be systematic and finish off the triangles like you normally do. Okay, so that's that. If you have any questions, hit me up. But otherwise, if you're handling this okay, then you're doing really well. Hang in there, keep working.